Okay, so we're covering still Dynamo, and we're going to get into some generative design, which is kind of what I'll also refer to as sort of a 1.0 on thinking about artificial intelligence as a design tool. And I call it a 1.0 on artificial intelligence or AI simply because we're not having a conversation with the computer yet, right? And so the computer isn't, we're not able to say, hey, look at this site, observe it, let's do some stuff with it and make it happen. This is still a lot of human level interaction with the computer. But when you see it start to work, you can really begin to understand, okay, this is our first step towards AI as a design tool. So all that said, because this is big, complicated stuff, I really do want to break it down with some simple vocabulary stuff first. Okay, so let's take like a big step back, the 40,000 foot high view, just in terms of where we're at. Okay, so like this is like design, right? This is 2D design. This is what we come from. It's always going to exist, this idea of drawing and crafting. It's the most visceral experience. It's the most sort of intimate experience that we have with the creative process. In terms of like what we teach, I mean, this is never going away. We feel like hands-on and all those things. It's still super relevant. And we think it always is going to be, right? Technically speaking, in terms of AutoCAD, right? If you're using AutoCAD as a 2D modeler, which in terms of my experience and practice, it was largely still being used as a 2D drafting tool, not a 3D modeling tool. So this is still largely lives in that 2D design mode, right? So this is sort of where we were really almost just a decade ago. We at that time, we were getting into 3D modeling, so that was sort of next level of engagement. So that's programs like this. This is 3ds Max. Programs like Rhino, without the addition of Grasshopper. SketchUp, Twinmotion, all live in this world of sort of 3D modeling, where essentially we're doing basic operations, we're doing some basic things, but the data that we're generating is simply object-based, basic information, basic data. These don't know that they're columns, they only know that they're boxes and they're stretched out and they're this weird shade of green, right? So let's close that because 3ds Max is a memory hog. So the next phase that we've entered into, and this is sort of like where we're at now largely in practice in architecture, is parametric design, right? So this is where all of a sudden we're getting into 3D modeling, but this object doesn't think of itself as a cube anymore or a box. It thinks of itself as a wall. And the entire program helps us work with that as a wall, from joining edges to knowing its identity and its materiality and its insulative capacity, its structural capacity, all of those things. So when we do this, when we create this kind of a model in a Revit or an ArchiCAD or Bentley or whatever, we have a lot of computer assistance going on, and we're building more data. We're building something that's beginning to get a bit intelligent. So the next layer on top of this is parametrics. And parametrics is when we begin building relationships. So in this instance, we've been working with FormIt and Dynamo. So this is something, where again, I can grab something from FormIt. I can use information that creates relationships between objects, and I can make modifications to those objects. I can make modifications to the relationship between objects, and then I can push that back into FormIt, right? So we're headed next after this, and so this is something, this is being adopted now, right? I mean, I think we're all in the process right now of figuring out how architecture is going to leverage this more and more. I think, it's starting out as an automated process. It's advancing to something that is more comprehensive in how we use it as a design and construction documentation tool. And we'll get into that a little bit more today. I think the thing that is next, one of those next big pieces that's coming, is this idea of generative design. So generative design, the best example that I've seen of generative design, it's not Zoom, there we go, is a phylogenetic tree. Okay, so this is not a phylogenetic tree of a building, but of primates, mammals, and fast evolving mammals. And essentially you can think of it like this. So if I have a base design, right, that lives right here, I can have an algorithm that begins to build options off of that base design. So I have this idea of an input and an output. And a program like Refinery is going to look at all of these different mutations and begin to decide on its own, and then begin to ask for assistance with guiding on which object or which mutation is the most favorable, right? So these different sort of permutations of this essentially genetic tree is allowing us to see more design options and how data relates to those design options. So that's kind of what we're getting into today. Hopefully I can get through all of this stuff here in the next 45 minutes. If this starts to run long, we can bounce it to another Thursday, but I'm going to go pretty fast through everything, and then we can see, hopefully we're getting through everything, and we can go from there and do some questions then at the end. If I get way too far off track, just throw something at me virtually, and hopefully we can get back on things. And hopefully we can stay, like I said, hopefully we can kind of keep this on time. But again, this is sort of the best way to think of this as generative design. So the first thing that I'm going to start with is this example that's been floating around for a while in terms of, it's called a 3-box. And again, we're going to start with FormIt, and then I'm going to switch to Revit, simply because Revit has so many more parameters that we can grab. Again, FormIt lives in that sort of early generation 3D design thinking. Revit, with all the different parameters, there's just more opportunities to do more with it. And as I got into what I was going to present with this, it became pretty clear that I wanted to switch to Revit pretty early as we get past sort of basic formal thinking. So with this site still that I've been working on, I thought I would apply the 3-box Refinery sort of drill to this. And I rewrote the 3-box. You can find it really easily off of any Refinery sort of website, or even when you're in the software, you should be able to see it. I rewrote it to simplify it a bunch, just so it's a little bit easier to digest how it's working when it doesn't look like a plate full of spaghetti to me. Okay, so right now I've got this FormIt session linked with this Dynamo section. So what I'm going to do next is I'm actually going to open up my version of what's called 3-box. So let's go to open. Nope. TechTalk8, Forms Rebuilds, and open. Okay, so right now I do not have this linked back in the FormIt, but if I take this piece of geometry right here and put that in, that should get my square back into FormIt. Yeah, there we go. So what this is, really quickly again, this is my base site, which is this outline. And what I'm going to do is make 3 boxes on this. So right now I only have one rectangle. If you guys remember this rectangle, this is really similar to the script or the graph that we put together for building programming. So I've got a cuboid defined by width, length, and height. And in this case, it's also defined by an origin. Okay, so its origin right now, let's turn it off. I'm just going to uncheck preview. Its origin is that little dot. So let's zoom in on this guy just a little bit so you can see it. And that origin is basically going to be the center point that this cuboid references, okay? Or that, excuse me, this cuboid references. So the one thing that I've done different with this that was in that programming graph was, in the programming graph, we could move it anywhere. This particular case, I've actually set up a UV map. Okay, so again, if we think about Cartesian coordinate systems, we have X, Y, and a Z, Z being height. Well, inside of a 3D space, if we want our X and Y to refer to a surface, it becomes U and V, or in terms of a 3D space, you'll hear it referred to as UVW. And that's simply because, okay, we can't reuse X, Y, and Z again. They're already taken. If we start trying to program, and we have the same letters again, the whole world's going to blow up, right, in terms of the 3D space. So we have X, Y, and Z referring to the world. We have UV and then often W referring to an object. And if you look at texture mapping, things like that, a lot of times you're going to see those letters again, UV and W, right? So it's not a, these numbers are now no longer based off of the world, they are based off of this object. So they're going to show up as a percentage. So if I slide my U, it is going to go, right now I have this set from 60% to 40%. So if I turn this back on, let's turn this back to preview. If I move my U, it's going to slide that back over 60 to 40%. And largely I've set those up to kind of as a really, really shorthand method to keep this box roughly within the site. The site parameters, 140 feet by 150 feet. That is roughly representing the amount of space that I have on my FormIt site here. And what I need to do next, let's undo that, is I am going to make 3 of these. And so this game that we're going to have Refinery play is really basic and sort of formalist in its structure again. But we want to have Refinery look at surface area versus interior volume. And the concept behind that as a method is, can I create the maximum amount of volume potential with the minimum amount of surface area potential as a study to do. So what I'm going to do is I'm simply going to grab this box right here, and I'm going to copy and paste. So let's rename this building 2. And then I'm going to paste again. And we're going to name this one 3. And then we need to do a few additional things to clean up here. This, because again, we're dealing with code, and I have inputs and outputs. And I'll show those here in just a second. But if I do have names that are going to attach to different variables inside of Refinery, if I have the same name, again, Refinery is going to throw back an error. It's going to say, well, I can't do anything with that because I've got multiple objects with the same name that are my key variables to work with. So each of these need a unique name. So anytime, not unlike when I was talking about genetics, we have input and output variables. So we have the exact same thing when we are dealing with Refinery. So right now I have a couple of key things to work with. Let's go back up to building 1. And so you can see that box in the background. I've got my building length. That is a variable of 6,000 square feet. I've got my height that I can adjust. So if I select one of those and right-click on it, you will see I have that set to is input. And what that means is that is going to be flagged for Refinery as something that Refinery can edit. Okay, so I've got the length flagged as an input, height and then its location or its UV, all flagged as inputs. As outputs, let's come up to here. I have area, which is going to be calculated based off of the surface area of the solid that gets created as an output. So that's something that essentially Refinery is going to watch. It is looking for what is that overall surface area output. And then I have the volume. What's the interior volume of all three of these cubes combined? So to make that happen, I've got to do a few additional things. And I'm going to save you the struggle of watching me pull up all of these node packets, but I do want you to see how they're all linking together. So right now I have these three boxes, and I'm going to put those into a list, okay, that essentially combines them together. So all of the data that creates each one of those boxes is now unified in one set. I'm going to send that list into a solid Boolean union. So in other words, it's going to glue them all together. If you've done any work in 3D, 3ds Max or Rhino, or well, even Revit has that command in as well, where you union objects together. That's essentially what I'm doing, because I want the area to be calculated, not the area of all three boxes, but just the outside area once the boxes are connected, and same thing with the volume, right? So then I'm outputting that number. When you see double, again, you have to think more like a programmer. So this double, that means a number. So I'm going to be plugging that number into my area calculation, and this volume into my volume calculation. And then these little nodes called watch simply let me see that numeric output while it's in the script. The watch commands don't really do anything. They're just sort of a visual indicator. So I'm going to plug geometry 1 to list 1, geometry 2 to item 1, and the third geometry as the second item in my list. That list connects to the solid. Then I'm going to send the solid both to my area calculation and my volume calculation. This solid right here connects to my area calculation, and then I can watch that area calculation. So right now, all three of those boxes are giving me 31,600 square feet. My volume calculation, and then my volume watch. So that's 321,000 square feet. So then I also want to take this solid and send that to FormIt. And then I want to take these three and turn them off so that they don't show up. I only want to see my three final boxes that have been unioned together and that are also being sent to FormIt in this preview. So if I look really quickly at what I can vary, now I can vary my height, my location, not only the length really, but the size of that square, and I can do that for each one of these three boxes, right? So from here, I could essentially slide these around and make a bunch of variables and see what happens. Or I could drop all of this into Refinery and have it do a study for me that optimizes exterior surface area versus interior volume based off of this set of inputs and this set of outputs. So that's what we're going to go ahead and do. So step one to do that is to go ahead and export for Generative Design. Oh, and this is a really good time for me to create a little bit of a warning. This is out there for consumption, right? This is out there to see how firms are using it, but this is definitely still beta stuff that's happening. So I'm not anticipating the software to crash. I'm not going to say that it's highly probable that this is going to crash, but I'm going to say it is a possibility. So anytime that I'm teaching that, I need to follow my own advice, and first step here is to hit the save button. Okay, so Generative Design, export, and this is simply running a quick check. Are there things in here that are known that Refinery is going to trip over, right? So this is all good. I can hit export. I can close this. Oh, and this is important too, because this is a tool that I can use to generate thousands of ideas, right? So this is important to note. Users, DBH, documents, AEC, generative design. If you start to run out of hard drive space on your computer, that's because this is filling up with thousands of these pieces of geometry. So obviously this isn't pretty complicated. This isn't very complicated, but you get into more geometry, exponentially more space that gets eaten up. So just kind of be aware of that. This can start to really consume your computer. So we close that. Generative design and create study. So this, if all goes as planned, is going to launch Refinery. And this was Form 3D builds right here. So I'm going to go ahead and select that. So right away you can see these are my variables. Height 1, length 1, UV 1, and then I've got 2 and 3. I want to minimize my area and I'm going to maximize my volume. And the method of study that I'm doing is an optimization, right? So this is going to run a series of these, constantly looking for and eliminating ones that the program doesn't think meet this criteria. So there are various ways that I can just run this as random, like move around the boxes, give me stuff back. But I have a task in mind with this, and that is maximizing volume, minimizing surface area. But I also know as a designer, I don't want it to look like junk either. So, we'll go through that process here really quick as long as everything goes as planned. Okay, so I've got optimize, minimize surface area, maximize volume. I'm not going to set any additional constraints, but I am going to look at this. I'm going to keep this fairly small, population size. So it's going to give me 20 sets. It's going to run through, before I get those 20 sets, it's going to run through the process 10 times and refine it on its own. The seed is basically the starting point of the algorithm. So if we all took this same script and we ran a population of 20, a generation of 10 with seed 1, we would all get the exact same results back. But if I wanted to see different results or different mutations, I could change the number on the seed. It's going to start the algorithm at a different point, and you're going to get different responses. Probably not drastically different, but you're going to get different responses. Okay, so let's go ahead and run generate. And this shouldn't take too long because we're not running very many. It's still populating them. And is it done? Yeah, done. Green checks for done. So this is kind of an interesting chart. This basically takes each individual option. Like if I select this, it will tell you what the variables are by highlighting that line. It's a little bit difficult to see and discern. The scatter plot, is what's useful as a really good tool, because I can set my y-axis to be my volume. So I want options that are up here. Because I'm looking for maximum volume, I can set my x-axis as area. So I know I want something that is as low as it can be here and as high as it can be here. So ideally, like the golden solution would be this. Not a practical solution, but it's sort of the golden solution. And so everything in design really is a compromise. I can highlight a few of my options, like right through here, and begin to see different forms that are starting to do maximum volume. Spread that out just a little bit more and see what else we get. Let's grab these options right through here. I still didn't get enough of them. I want to capture that dude right there too. So we can start looking at these forms that are beginning to give us, that's terrible, maximum interior volume, minimum exterior volume. And I can determine, that to me, architecturally speaking, is one of the more interesting ones. So given that as a variable, and again, if I run more iterations of this, I get more options, more things that I can kind of call through. But given that, I can say, let's open that one back up in Dynamo. Let's go ahead and close Refinery. Let's say yes, and that's going to reset all of my variables to that specific what do I want to call this? It's going to reset my graph to the settings that were in Refinery to build that piece of geometry. So again, if I look at that in FormIt, I'm going to see that specific take right there, and that really needs to be rotated around for sure. So let's rotate this dude like that. Much nicer on the street side there. Okay, so to refine that one more time, because that's kind of the point of Refinery, I can take this again and I can say, okay, well, let's export this again. And let's create a new study. And rather than simply looking at this as an optimization, I can also do like this, right? So there are my settings from the sliders inside of the Dynamo script, right? Those were my variables. I can now create 40 solutions that are different variables close to these numbers to see what I get. So let's go ahead and generate those. So this is going to give me 40 new solutions that have similar area, similar volume, and similar form. Right, so that's already done because there's not a lot of evaluation happening. These are more at random, but these are randomly generated forms similar to what we had. And so let's say I like that one better, or maybe that one. That would be even better if those two are higher. But I'm hoping everybody sort of sees where this is going. So this is a very simplified scenario. And again, yeah, I know that there is this sort of cross check between area and volume. I don't know. I mean, in terms of energy, in terms of cost, I understand that that would have some variance. But again, to me, this is a very formalist kind of exercise. So that said, I wanted to do something that, again, simplified for sure, but would start to look at these tools in a more practical, day-to-day practice kind of sense beyond this. And then when you start to think about, okay, how could I combine what I'm going to do next with an exercise like this, I could start to say, okay, I could take some of these techniques and really begin to master plan a site, thinking about these larger variables and how they would work. Okay, so let's go ahead. I'm going to close down Refinery, and I'm going to close down this version of Dynamo. Everybody kind of with me so far? Any questions? So this situation is looking at Revit and Dynamo to generate an occupancy load. And to keep things relevant here sort of during a pandemic, we thought we would take a look at this as something that you might want to be sharing with clients, especially if it's a school or a restaurant, something where occupancy load is going to change dynamically based on CDC guidelines. So let's start really quick by looking at, well, let's just reference this really quick. This is a terrible floor plan I just generated for reference just so we could run these things through a test really quickly. And we're going to use Dynamo to calculate this. So it updates dynamically, and we'll look at bringing those occupancy loads directly into our floor plan as well, pushed in from Dynamo. So what we do know is we need to keep a separation distance of 6 feet. So just kind of thinking through this a bit logically, this started with saying, okay, let's give somebody their own personal space, about a 1 foot diameter, 6-inch radius. From that point, we do 6 feet worth of separation between those two circles. And just for the sake of generating area quickly in terms of how much space it's going to take, I just put a wall around that circle. And from there, I can select my room tag. I can edit the tag type and turn on area. And we can see that a person needs 38 square feet of space at a minimum to maintain social distancing of 6 feet per the CDC guideline recommendations. So turning that on here gives me my square footage numbers everywhere, but I could take this and I could drop it into an Excel spreadsheet, or I could simply do the math on each room. And on a floor plan this size, maybe that's not that big of a deal, but when we get into larger buildings, or when you get into needing to go back and open up multiple buildings and generate this kind of data, the amount of error that you're going to introduce and the amount of time that you're going to introduce becomes pretty dramatic. And so anytime that I have a repetitive task, I'm always looking toward a tool like Dynamo to help me do this quickly, accurately, and effectively, right? So let's go ahead and launch Dynamo. And I already have the graph built inside of Dynamo, but I will walk you through exactly what that is. So I'll spare you the details and boredom of watching me build it, but we'll walk through it step by step. It's a very simple little thing to build. So let's go ahead and launch Dynamo. And we will open up the occupancy load graph. And this is a very simplified version of this. I like things simple. You could add in more things with this, but this is simply a way to quickly generate those numbers. Okay, so first of all, this is grabbing a category for me out of my Revit file, right? So I'm opening, it's very important that you're opening Dynamo from the view that you want this to work in, because this is grabbing the rooms out of Revit in that current view, right? So that becomes a category and generates this simple list of elements, because again, at the core of things inside of a computer, it's all ones and zeros, right? Those rooms don't really know what they are as I stretch them into Dynamo or pull them into Dynamo. So I need to do a little bit with them, right? But this gives me a basic list. From there, I want to generate the room area. So again, if you're fairly new to Dynamo, how I'm pulling these in is I can either do a search here, or I can right click and let's just do room dot area, pops up. And so this essentially is going to calculate, it's going to look at this room tag, right? So room 0 is 3555979. That's its ID tag essentially. And I'm feeding that as an element into an area, so it's pulling the area out of that information and turning that into a number, which is what this word double means. Let's go ahead and delete that node. From here, I need to find my occupancy load. So I've got my area, and I need to find the occupancy load. So if we minimize this again, and let's go back into Revit, 38 square feet is the minimum amount of number that a person needs for that 6 feet of separation. Let's go back to Dynamo. So that was, I'm going to just modify this number to 38. So now I have 38 as a number that's fed in. So this is divide, right? So this is simply if I right click and look at my math functions for divide, find that. That's color divide, wrong divide. Let's type that in a little bit more thoroughly there. Divide, there we go. So this again is just creating a variable. Number in divided by number. So x divided by y creates a variable, which pushes that number into what is called a math floor. And essentially math floor is rounding down, right? So let's build a watch list right here underneath divides. Let's just type in watch. And we can plug that variable in, and we can see again my room list and the number generated, right? So for my area, let's copy that watch list. So just a Control C, Control V, and let's plug that. Going backwards here. That number into this watch list. So you can see that is my area. 480 divided by 38 is going to be 12.6. I can't have 0.6 of a person, so essentially I need to round that down, which is called floor. So we're going to floor the integer. So if I look at that on my watch, this is surrounding 39.7 to 39, 12.6 to 12, so on and so forth, right? So that needs to be organized into a string, which is a value. I need to send this back into Revit to the occupancy slot. And so that's capital O, occupancy. Really important. If that is a lowercase o, or if I have a typo, it's not going to send it back to the correct parameter in Revit. That is essentially then creating an element. So my element, that is my output. So I am putting in my room element, parameter occupancy, and the value from this string right here. So that has already sent this number back into Revit. I have this set to automatic, right? So if I look at my rooms now, I can select not the room tag, but I want to select the room. So I'm going to use the tab key, select a room. I can scroll down, and now you're going to see capital O occupancy with 39, right? So that is room 2. If I trace that back into Revit, you'll be able to see, or not into Revit, but back into Dynamo. Wrong button. There we are. I can see there's that number 39, so that was tag 1, essentially, and you can track my square footage to the occupancy load being rounded down, and then that being pushed back into Revit, right? So it's great that I have that. I can put that in a list, all that stuff, but visual thinkers that most of us are in architecture and how we want to talk through these kind of things with clients, it would be nice to go ahead and get that on the floor plan. So this is a bit of a hack to be for sure. I don't know as much about room labels and editing labels as I should. So apologies for showing a hack, but to get this quickly on the floor plan, what I'm going to do is I'm going to select my room tag here, and I'm going to click Edit Family. And I'm essentially, this is the hacky part here, I'm going to overwrite my volume to become occupancy load. So I'm just going to select volume. I'm going to edit that label. I'm going to remove volume. I'm going to add occupancy and say, okay. So it does change the word here. I'm going to load this to my project, overwrite the existing version. And now if I select my room label, I edit the type, and I turn on show volume. This is the hacky part, right? I would love for this to say show occupancy, but it doesn't overwrite that. That's where, feel free in the comments below in YouTube, show me how I need to, what step I need to go through to overwrite that parameter and actually turn that into show occupancy. That would be great. But once I do that, I will get my number, right? So now I have listed into each of my rooms the number based off of 38 square feet as a minimum number for my occupancy load, which again right now is a very relevant parameter. This is still dynamic, so if I were to stretch this out and reshape it, all the numbers automatically update and change based off of the parameters that I'm putting in terms of calculating the area, dividing that by my occupancy load, and then generating that new occupancy number for me. Looking at that, our next task then was to think about, okay, how do we begin to lay out desks in this? And so again, this is a really excellent task for something like Refinery. So the first thing that I'm going to do is I'm going to do a little bit of a cheat on this, in particular because what Refinery can do is it can grab this and turn it into geometry. I should say specifically, Dynamo can grab this room outline and turn that into geometry to test a desk layout. But it doesn't really quite yet have something here and here for me to say, okay, those are doors, so please don't put a desk here, right? So what I'm going to do is the little bit of a hack here is to just come in, and I am going to use the room separator tool and just draw a little bit of a guide here to here. and another one from here to here. Understanding that that is changing my numbers, maybe that's a necessary thing, but I wouldn't want to throw off other data and other locations if I'm looking at volume and things like that. But this is going to help this room kind of determine what is a potential for desk layout. And I could do, sort of one more thing with this as well. Like let's say that I know I'm going to be teaching here, so I can't have desks in that location either, right? So let's go ahead and hit the save button. And let's go back into Dynamo. And so this is still linked with that level 1 floor plan. So I can simply hit save. It's going to remember all of that stuff. And I am going to open up a new graph called Room Layout Options. So again, this is something that, again, in terms of me doing research on this, this isn't an original graph by me. But this goes back to that concept of you need to know how to drive Dynamo. You don't always necessarily need to know how to change its oil, right? Because for real, I don't know that I can build this graph. This is a fairly complicated thing. But I want to walk you through it really quick. But I do know enough about this to drive it and get some interesting results, right? So as a starting point, this is going to allow me to grab a room in Revit. So I'm simply going to go select, minimize, and let's grab, I'm going to use my tab key to grab that room. Okay, so now I can switch back into Dynamo. And you can see it's already started its process. Let's kind of zoom that in so we can see it. And put that at an angle that we can see it a little bit better. So it's already started to run its magic just by me grabbing that room, which is really cool. Sorry, a little bit of a brain meltdown. I think I think I've opened up a slightly older version of this graph, so I need to add one more piece in here. The remember block basically allows me to iterate over and over again without losing things. And I'm hoping, I don't remember, I'm honestly saying I don't remember if this plugs in here or here. I think it plugs in after the element solids. So I just need to look at, this is going to geometry. Okay. So I'm going to plug remember into my here. And this goes into my geometry here. Turn off preview so we can still see it. Okay, hopefully that doesn't cause a massive error later. We'll see. If it does, then we know what I've done wrong. All right, so this, again, first part, I grabbed the room. This is remembering the geometry so that I can iterate. This is the office geometry. So this is, I believe this is looking at the overall perimeter and turning it into something that I can visualize. Zoom out here again. This is the desks. Okay, so this is helping define what the desks are. This is dividing the desks into construction planes, right? So this is essentially where the desks are going to be. So it's their hosts. Clearance and boundaries. So if you look again, I've got a desk and then it's clearance that we're working with. And then this is removing any desks that happen outside of this boundary. So in other words, if I have a desk that lives out here, outside of the scope of the parameters, it's essentially deleting it. So this sets up my outputs so that I can send these into Refinery. So I need to open up, I want to make sure that I get this set up correctly. Again, I'm going to open up Photoshop and open up the back end of this graph here really quick. So I definitely don't want to cross any of the wires up as I'm running through this in a demo. I meant to do this before I started the presentation. So the variables, let's talk really quickly about the input variables. The input variables that I have that Refinery can work with essentially are the edges. So if I make some modifications with this, you're going to see how the edges work, the rotation of the desks within the room, the position on the room surface. Again, so this is looking at this surface, again, as a UV space. So it's essentially sliding those around within the UV space. So relative, so again, you're seeing that as a percentage, 100% to 0% in terms of the perimeter of the room. I have an end offset that I can work, in other words, what kind of clearance do I have in terms of the edges, and then non-variable inputs. So in this particular case, we would have something like a 4-foot by 5-foot drafting desk. We're not too worried about clearance on the edges because that keeps us outside of that 6 feet. But then, so let's just change that a little bit. If I increase that, it changes the spacing, but we're pretty good with the spacing, so we should be able to set that to 0 because we have such huge desks. And then circulation around the outside. So we're trying to create sort of a buffer. We might increase that all the way to 6 in terms of the spacing around. So these are things Refinery is not going to take a look at. These are not variables. So they aren't marked as either an input or an output. These are known things that I want Refinery to have to work with. All right, so I'm going to look at the back end of this chart here. One second while I open this up. Oh wow, this is going to be terrifying. I have to do it from memory. So occupancy load is that one and that one. Okay, well we'll see how it goes. This will kind of be fun. Okay. So my output variables right here. If this goes terribly wrong, I think that I can open up a different version of this that is completed. Yeah, I'm not going to be able to do this by memory. No way. Let me open up a different version of this.
Hey, Dave.
Yeah.
We are approaching 1 o'clock. I'm fine if you keep going, but
yeah, as long as everybody's okay. I mean, I'm right at wrapping this up. As long as, hey, there we go. As long as, yeah, as long as I found the one that actually has everything connected, and this one does. So this is essentially, in terms of looking at the output, I am grabbing my surface area. So let's go back here really quickly, and I want to grab this room one more time because I need to reestablish. So I'm going to go select, minimize Dynamo, and let's select this room. I think I missed it. There we go. And let's see if that's got my room correct. Yeah, that's got my room correct now inside of Dynamo. Okay, so I've got my room correct. I can set, let's reset these parameters really quick. So my desk width was 4. My length was 5. My clearance was 0. And circulation spacing around the desk is 4. Okay, so I'm pretty comfortable with that, at least as a starting point. And then, of course, I could marry this against that 154 square foot on my occupancy load, and you'd be able to see a few things from there as well. So essentially, I'm taking my desk length, my clearance, my width, all into a system where I can begin to see outputs, right? So this also gives me area utilization. And this one even takes it a little bit further. Okay, how private are the desks? And that's based off of looking at how many desks are further away than 12 feet from any one individual desk. I'm not sure if that's a great quantity to understand being private, but that's sort of what this program used, is trying to build a variable for that. So from here, I can look at workspace area per person. I believe that's one of the outputs. Total area per person is an output. Area utilization, so that's those two divided as an output. And let's see here. Total number of desks should also be an output. So again, I can come back to Generative Design and I can export this. Hopefully won't make any error messages. Export. Create a study. So, and if you'll notice, like if I scroll down in here, there is already one of these set up, workspace layout, which is much more complicated than what I'm showing. Believe it or not, because this is already a fairly complicated graph to me. This actually takes into place columns, windows, views out of windows, distances to exits, so on and so forth. So this is, I'm trying to show a more simplified version and get through it sort of quickly and gracefully here, somewhat ungracefully. This was room layout options, refine 1. So that should be what I'm dealing with right there. So I want to do an optimize on this that is looking at a maximum number of desks where each person has a maximum amount of space, minimum area utilization, and let's maximize the private desks as well. Okay, so we'll hit, this is going to again run 20 options. It's going to cull them out of 10 different generations of doing this. So you can again think back to that early sort of genetic chart where we're actually going 10 stages deep in terms of running this. And then we'll see what the results are. And then the idea after that would be same kind of process of, I like this option, let's add in a few more variables and let's see if we can refine the results. It's also one of those ideas that I could take something like this and present many different options in terms of how this would work. I can leverage all of these options as a designer and see, okay, which ones are starting to make the most sense. Options are good, right? I mean, that's just something that we always want to have. So anytime I can build more options, I feel more confident that I'm selecting the right kind of solution. So again, that's done. I am going to switch this again to the scatter plot. And I'm going to set my y-axis for the number of desks, my x-axis as workspace area per person, and we can immediately start to look at the options that have the most, right? So this isn't too surprising, but maybe it's a little bit dull. But we can start to filter out. and start grabbing up here which options start to do the best at meeting more of those criteria. In terms of that scatter plot, I can also start doing some things like if I want to see not just the number of desks, but let's say area utilization as a different size, I can start seeing those show up as different options as well. So again, the ability to create and generate really, really quickly a lot of options is a really cool thing to have as a tool. That's where I planned on stopping. To be honest, I'm a bit shocked that I'm only 6 minutes over on time. But I think we have a few minutes if you have some questions in terms of how this works. I guess before we do the questions, I think the closing idea I would have with this, in particular looking at this example, is I think you can see how this graph plays out in Dynamo. Let's say that this is the most exciting option. So I'm going to go ahead and open that in Dynamo. And so it should update that plan for me. Seeing how this starts to work and play out, and of course that didn't work. Oh, no, maybe it is going to work. Or maybe it's going to crash. Oh, no, there we go. Seeing how that starts to play out, to me, more exciting than thinking of this as room layout and that kind of thing. Definitely is the idea of how I could start to manipulate this Dynamo code and take ownership and authorship of this to start thinking about site plans. Doing a large multi-zoned facility that starts to take into account streets, roads. One of the other things that I will close here and point out is there are packages that you can begin to add on. So if I look at packages here and say search for a package, I could set this up to be a solar study as well. So I just go into, so there's more to Dynamo, I guess what I'm saying, than what it ships with. So if I just say open packages, so these are things that have been written and are being distributed. So if I look for solar packages, I can add in solar analysis for Dynamo. And I can simply install the latest version of that. And it's going to add that into my list. So I could be using, I'm thinking about this as an entire site. I could be using solar gain or daylighting as one of my variables for Refinery to make adjustments to my layout. Right, so that shows up, that package. These are little bitty things usually. So that's already here in Analyze, Solar Analysis, and I can start to pull in my local weather data and how that analysis is run. I can set that as a variable output for Refinery and begin to manipulate and move things around or even manipulate openings and walls to vary light quality on the interior. So this is really, think of these as a starting point and how this can evolve and help us as a design tool is, I certainly don't want to say limitless yet, but it should definitely get your wheels turning for what the possibilities are. So I'm going to stop the screen share, hopefully intentionally this time.
Hey, David.
Yeah.
When you were adding on that script, I noticed that it said that, this script contains Python, blah, blah, blah.
Uh-huh.
Do you see any value in learning Python scripting? Or is it more that as long as you can kind of learn to drive the visual scripting tool, you can kind of figure it out?
I think, so to me, it's a multi-step process, Andrew. I think what you're looking at doing is getting into Dynamo and seeing how far you can push Dynamo and Refinery first. Then when you find, oh, I've got this gap, nobody has put together a code packet for this yet, and I need this, and this is something I'm going to need over and over and over again, that's when you start looking at it in terms of, I need to learn how to write my own code to do this specific task, and that's going to be a worthwhile investment of my time. From my perspective, like as a teacher, I've thought, okay, should I be learning C++? Should I be learning Python? And the reality is I haven't found tasks yet for me that I can't complete in Dynamo, or Grasshopper, right? Because those are your code writing tools. Those are your visual code writing tools. So I look at my daughter's curriculum, how they're teaching kids to write code is all based on the same sort of visual scripting method. So I don't want to say that those are outdating C++, Python, so on and so forth, but you can accomplish so much with those that I really think that's, you would be starting from scratch with something like Python, but by the time that you get caught up and feel really comfortable with that, whatever you want to do, somebody has probably created already in Dynamo. So it's like, in terms of how you invest your time, I would be digging deep into Dynamo first before I would start doing things with scripting in Python, scripting in C++.
Cool, thank you.
Hey, Dave.
Yeah.
We just had a quick question. Refinery is accessible, free, all of that right now, or
yeah,
what's the status?
It is. So Refinery is part of Dynamo. So when you launch into Dynamo, it should be showing up. I did find, for me, like, it worked perfectly right out of the gate with FormIt, and it was in that top drop-down list. On Revit, when I launched Dynamo from Revit, it was not showing up. So there was a patch that I needed to install for Dynamo. I think it was like 2 megs, something like that. There was something corrupt in the original files that were distributed for 2021 Revit. That was probably too harsh for me to say. I don't know that it was corrupt. It's probably something more on my end on my computer, but it wasn't
I
showing
actually
up.
had the same problem, Beach.
Okay. But there is a patch for that, super easy to install, and I'd be happy to help anybody out with that. I'm afraid to put in a Google search string right now to try and get that same thing to pop up, but it was pretty easy to find.
Okay, good to know.
Yeah, but it's all free. It's part of the service.
Jade pointed out you technically finished in 59 minutes because we didn't start till 12:07.
I appreciate that. The other thing that I would say about Refinery, I think that their goal is this is Autodesk goal, will really be considered part of Dynamo and part of what you're doing in Revit. If you open up Revit, once everything is installed correctly, you'll even see underneath the Manage tab, the Generative Design tools are buttons on the tab. So those things already exist. I think their goal is to see that as part of it. Originally, they were going to do all of Refinery in the cloud. So it was going to upload your model and download those things back. And I'm sure that they were thinking cloud credits and stuff like that. They've started to locate that all on your computer system now, which is good and bad. I mean, I'm kind of happy that they're not thinking of that as stuff that happens cloud-based, that they want to microcharge for. Because I think that, especially in terms of learning how to use this or applying it as an office, I don't think anybody would want to pay sort of these microtransactions, to get it going in an office. The downside to that is it does have the potential of really creating a lot of data that lives someplace on your computer. So just be aware of that. I think, in terms of listening to a few lectures on this, essentially part of what Refinery is doing is it's launching 4, 5, 6 versions of Dynamo that exist in the background for a little bit while it's running these, and then collapsing them back down, which is fine, but it's also, again, it's eating up a lot of RAM. It's going to generate a lot of data, especially when you get to more complicated things. So just be aware of that. So that's the downside of it not being in the cloud is all that data that's happening, all that processing is happening at your local machines. But to me, that's a much better solution. I'm happier with that as a user.
Good. Yeah. Hopefully, as things would evolve over time, we'll have more cloud space be accessible and everything will work in tandem, but we'll see.
Right.
good morning, though. If my computer crashes, I'll look there first.
Yeah, and I would say, I've had 2 or 3 crashes, but they've always, they've been, oh, well, this button isn't working anymore, and I've had to kind of restart everything. But I haven't had it take my entire system down yet, which is good. So, I mean, I think it's, again, the tool set is ready, it's well evolved, but it still has both a learning curve on our end, and then us pushing how we're wanting this to work back up to Revit, so that some of these specific graphs, like if you're seeing something, oh, we could really use this, and we would use this as a tool over and over and over again, that some of those graphs, I think that they are happy to begin developing those and folding those into the tool set for us to use automatically.
So that social distancing script that you found, did you just find that on an open source? Is that something you could share with us? Or
yeah, no, I'll of course, no, I'll send it to you. I basically rewrote that one on my own, based off of another script that somebody else was using to find occupancy load. And frankly, it's a little bit, what they were doing was a little bit too complicated in my opinion, because they were sort of parsing rooms and separating it all out. Again, I haven't practiced in a while, right? I'm now a full-time academic, but to me, it's just like, I just want to see that number on the floor plan. If I can see that number on the floor plan, that does me a world of good. If I'm trying to do it with a hospital, okay, I get it. I need to parse it a little bit further. I don't need this to create that data for 5,000 rooms. Sure. But for me, I think 90% of what we do, falls into that. Just give me the number and let's get it on the floor plan and let's print that plan back out again. And that might be something really, really valuable to have.
Yeah, definitely.
So yeah, I'll send that to you as soon as we're done here. I'll send that to you for sure.
Awesome. Thanks so much. This is definitely one to send out the recording. I'm sure that people will be interested. And at this point, they need to keep up.
Yeah. Again, that's what I will say as well. There are ethical debates on what this is going to mean for sure. And anytime that's coming in, I think we had that with AutoCAD, saying, "Oh, as a drafts person, does this eliminate that job?" And I think we were able to answer no. It did not eliminate that job in that category of work. And then when we switched to BIM, what is this changing? How is this? And less of an ethical discussion there, I think. All of a sudden, this idea of generative design, and again, it is in its infancy. What does that do to us as educators? Like, are we going to be teaching, oh, well, let's pick the best design solution rather than let's design the best design solution? Or are we becoming curators rather than designers? Anytime I see something that has the potential of being so transformative that it has an ethical discussion around it, that begins to state its significance right there. And from the people that I know at Autodesk working on this, they actually have teams debating the ethics of what to release and how to release it and how to teach with it, what maybe is going too far. So, that is how transformative the potential of this tool set is. So yeah, this is one of those things to get out in front of so it doesn't run over us.
That's exactly right. You were, definitely curator, as you said, when you went to that graph and chose, and you can just see Matt pointed out that one of those desk arrangements had all of them clustered except for one person off.
Right, exactly.
That takes a human brain to decide.
And I think that's the idea, is that you find something I think that's the right direction. And then you take ownership of that as a designer and authorship of it.
It's a tool.
I don't know that it ever, will be something that, hey, that's my final. But I do anticipate this, I don't know, maybe 5 years out, maybe it's further, maybe it's 10 years out, that at the end of a workday, we would be leaving and saying, setting something up and saying, I really want to be able to see, I want you to run 100 generations of this task, and I want you to provide the 20 best when I show up the next day. I think that is something that will become part of a work routine that we kind of regularly do, that we have these sort of massive generations that we do that take a while to run, even on more advanced computers, that we can start to edit and refine in the next day kind of thinking. So it's interesting. It's one of those. I definitely think it's going to stick. I definitely think this is something for us to start to figure out how we fold it into practice and to definitely get out in front of the technology. Cool.
Well, let us know what's next. If it's more refinery